Welcome. In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using either the PowerBasic Windows or console compilers. Today we will look at saving individual frames and data of our star migration simulation. This was our application at the end of the last video. Our application displays a graphics window on screen and starts a star migration simulation. We're going to be covering two areas in today's video. We're going to be capturing the graphics window at particular points during the simulation. We're also going to be capturing data. The data will be stored in the data folder we see in here. And the images of the graphics window will be captured into the images folder. So let's go and have a look at the code. At the beginning of our code are a number of constants. These control the operation of our simulation. We're currently covering 10,000 years of our simulation and a star count of 200 stars. So for today's video, I'm going to reduce the number of years down to 5,000. But we'll leave the number of stars at 200. So we're going to first of all look at data generation. The object is to create a CSV file at the end of each year. So let's go and have a look at the PB main function. In our PB main function, we have a for next loop, which counts from the year number 1 to the maximum number of years, which we've now set to be 5,000. Within this for next loop, we're calling a function called moveStarsOptimized. This is the function which recalculates the position of the stars due to gravity and positions them on the graphics window. If we have a look at this function, we'll see this is running in a nested for next loop. Once all the calculations have been done and the stars have been positioned for this current year, we place them on the graphics control. So once this has been done, we want to output our stars to a CSV file. So we're going to create a new function called output stars, taking a single parameter, which is the year number. And there is our call to our new function, output stars. So here is the skeleton of our new output stars function taking its single parameter. I've created 3 local variables: long file, which we're going to use as the file handle for the CSV file we're about to open; long R, which is going to be our star counter; and str file, which is going to be the string of the name of our file. As we're going to be stepping through the stars array, we're going to use a pointer here, so we'll create a pointer as well. For the purposes of this application and video, we may not want to dump every single year's data, as it would of course create 5,000 files. We're going to limit the number of years which this function will output data. If the year count is greater than 10 and the year count is less than the last 20 years of our processing, we're going to exit this function immediately. From an efficiency point of view, it would probably be more efficient to do this test before we actually call this function. But for the purposes of today's video, we'll leave the code where it is. Next, we want to create the name of the file we wish to save. We can do that very easily by using the format command to turn the year number into a string. Then add 4 zeros to the start of the year and keep the rightmost 4 characters. So our year number will be 0 filled and always 4 characters, and preceded with the word turn and an underline. Next, we want to open our file. We can do this quite easily by picking up the next available file handle by using the free file command and populating our file long variable. Then we're going to open to the executable path and the data folder. And into that, we're putting our file, which will be a CSV extension, and we're creating this file for output using the handle we've just obtained. And our next task is to print the headers for our file. We're wanting to output the system, the X, Y, and Z coordinates, the mass of the star, the velocities in all three coordinates, the owner, should there be one, and the current status. Next, we'll want to do a for next loop. This is going to step through each of the stars in our stars array. So first, we will pick up our pointer using the var pointer command. And now we can output all the data in our array to the file by quite simply using the print command. In this print command, we're using a couple of additional constants. The constant for the double quote character and the quote, comma, quote constant. This allows us to frame up what we're putting out to our file quite easily. And there are the use of our pointers. We're wanting the star number in the array, the X, Y, and Z coordinates, the mass, and so on. And we finish up by having a double quote on the last column. And our final act within this function is to close the file off by using the close command. It takes a single parameter, which is the handle of the file we opened when we started to write to the file. So before we run the application, there's one additional change I want to make. The user has the ability to click on the X at the top right-hand corner of the window to close the window down. For Graphics Windows, this does not terminate the application, it merely closes the window. The application will still run away quite happily in the background. So we want to detect when the user closes that graphics window, should they wish to terminate the simulation early. So if we go back to our pbMain function, where our main loop is. In here, we're going from the year count 1 to the maximum number of years. So what we're going to do in this pbMain function is, within the for next loop, we're going to test to see if the graphics window is still there. We can do this quite easily with the Windows API call. When the graphics window is created, it populates this hwin variable. This is the handle of the window, and this is what we can test. So after we have redrawn the graphic to the user, we can then test for the presence of the window. And we're going to do that by using the isWindow function, which takes a single parameter, which is the handle of our graphics window. If this returns false, then the graphics window is no longer open. It has indeed been closed. And we're going to create a label within our code called terminate. And we're going to use the goto command to jump to that label when we know the window has been closed. The goto command is a very old command in BASIC and generally not used a great deal anymore. But for this type of exception handling, it works very well. So if we compile our application, and then we'll run it from the folder. So as we will see in the data folder at the moment, there are no files. So let's go and double click on our star migration application. And there is our application running quite happily. And if we go back to our folder and into the data folder, we'll see we now have 10 files. These are all CSV files generated at the end of each turn. We've set the system up to generate the first 10 files and the last 20 during the simulation. We'll leave the simulation running in the background and have a look at the files. I have associated CSV files with another application, which is also written in PowerBasic, using the My Little Grid. As we can see, we have a list of 200 records, which in this case is all of our stars. So we have the system number, number 1 for the black hole, and its coordinates on screen, its mass, its velocity, the owner and status. So as we can see quite happily, we have the locations and data for each of the stars. And the fact we have captured the data for each of the turns means you can compare the data. If we look at turn 10, we'll see the black hole, of course, has not moved, but all the other stars are now different. If we bring turn 1 and turn 10 up at the same time, we can see there is a marginal difference between star 2, x-coordinate, in turn 1 and in turn 10. And the velocities are very similarly different. So this gives you a method by which you can dump data out from the arrays to CSV files very easily. Our application is getting close to the end of the run, so we should see the last 20 files appearing very shortly. And we can then do a comparison between the very last file and the very first one. And there is the last of the files. So let's look at turn 9999. I'll place this one up here, and we'll also look at turn 0. And there we can see the black hole has not moved, but the other stars have actually moved. So we've now completed a data dump of all our stars in the array. So next we want to populate the images folder. So as we did before, we want to do something within this for next loop. As there are going to be some 5,000 turns, we may not want to keep all 5,000 images. So again, I'm going to be limiting this to keep the first 120 images. This will give us 120 frames, which we can use to build up a 2-second animation at 60 frames per second. So to do this, we're going to be using GDI+. At the beginning of the application, we've already included a library function, GDI+ included functions. And we're going to be making use of functions within that library. So outside of the for next loop, we want to actually start up GDI+. And we can make a call to that function within our new library. We're creating a dword variable as a token, and that will be populated when we call startup GDI+. And at the end of the function, when all the processing has been completed and we're terminating, we can then shut down GDI+, passing a single parameter, which is the token we obtained at the beginning of this function. Now in the middle of the function, within the for next loop, we want to capture the first 120 frames of our animation. And here is the code to perform that function. We have a test initially on the year count. If it's less than or equal to 120, then we want to keep that frame. We want to generate an image on our images folder. And we're going to populate a variable called file output. This, using the right dollar approach again, will be preceded with the word image and an underline. And the remainder of the name of this file will come from the year count. And we're also going to be calling a new function within our library called save graphics control. This can be used to save whatever the current graphics control happens to be. So if you have an application that generates graphics controls or windows, then you can use this to dump that screen out to file. It takes only a single parameter, which is the path and the name of the file you wish to create. We can see the file output variable has already been declared at the beginning of this function as a W string, set for the maximum length of the path. This is needed as within this library function we're going to be calling some Windows API calls, which need our variable as this format, wstring-z. So if we attempt to compile our application to make sure it compiles cleanly, and if we go into our images folder, we'll see there is nothing there at the moment. And if we run the application once more, and while it runs, we'll go into our images folder, and we can see we now have 120 images sitting in here quite happily. So if we have a look at the very first image, we'll see there is a snapshot of all the stars as they existed at the beginning of the application. And as we're only interested in the 120 images, let's go back to the application and close it down. And the application and the graphics window have now been closed. So what can we do with 120 images? Well, from here we're going to go into DaVinci Resolve, which is the application I use to edit these videos. And here we are inside DaVinci Resolve Studio. You can of course use the free version to do what I'm about to do here. What we want to do is we want to grab all these 120 images and drag them onto our timeline here. And if we select all of the files within this folder and just drag them on to our timeline. And as you can see, it has created a short 2-second clip. We can of course generate a great deal more than 120 images. But dragging these onto the timeline in DaVinci Resolve allows us to bring them in as part of another video. So if you have an application which generates lots of images, you can use these to create animations. So in summary, what we've done today is add 2 additional features to our star migration application. We can now dump out the data for all of the stars for each of the years processed. Additionally, we can also capture an image of the graphics window at the end of each processing cycle. This allows us to save as many frames as we wish to the images folder. These can then be used to add together to create a little animation. This logic will of course operate for any graphics window or graphics control. Hopefully you'll find these functions useful in your applications, but that's it for today. Thank you for watching.